It is time to get into Unit 6. And Unit 6 is where we take Unit 5 and we're going to challenge ourselves and we're going to go further. We're going to actually get into algebra and work on solving for our variables. So let's think back to Unit 5. In Unit 5, we focused in on the word expressions. And we said that expressions are any math problem that does not have an answer with it. And now we're going to go into that other type of math problem, an equation. And an equation starts with equa, which is where we get our word equal. So we know there's going to be an answer with it. And we're going to be using the substitution method as we get started here to figure out which of the possible numbers they give us is the correct one, which is going to match up and give us an equal answer. So being able to use our math and substitute in, these are the easiest ones. But first we need to understand that what we're talking about is equations, equa, equal. We have the answer given to us, right? So if we know that it's going to be equal, then we're good to go. Now, how are we going to work through it? So when we have an expression versus an expression, so what we're being told then is when I have an equation, I have an answer, then it's an expression separated by an equal sign to another expression. So both sides have to become balanced. They have to be equivalent, also with the root word of equal in it, to each other. So when I do my substitution method, then once again, all that means is we're going to be given a number or a set of numbers, and we're going to plug them in for our variables. Our variables, once again, are simply letters. So we're going to be given a number, we're going to plug it in for the letter, and we're going to see if it does become balanced. Right? So when I plug it in and I do the math, I want to see if the left side and the right side are indeed equal to one another. Therefore, it would be an equation. So the work they're going to ask us to do is to take an equation, so a math problem that has an answer with it, solve by substituting. Once again, substituting is where I'm going to be given a value to plug in place of my variable, which is my letter. And in most of these, we're going to have 3 different math problems we have to show. The math is not difficult. The most difficult thing for 6th graders is the desire to want to show all the work that is asked of you. So you have to show the 3 math problems that you're going to create. So as we can see, we have the math equation of x plus 3.5 is equal to 7.9. So what we're going to do is we're going to plug in, we're going to substitute in for the x on these 3 different values. What 3 values? Well, one time it's going to be 3.4, one time it's going to be 4.2, and one time it's going to be 4.4. Until we can see that on both sides of the equal sign, we get the same number. What number are we looking for? Well, on the right-hand side, we can see that it's just 7.9. So that's what we're trying to solve for on the left. Showing the math means that you can tell me what, not only what I'm substituting in and where, but how you do the math, right? So right now we have decimals. And our first one that we're going to plug in with is 3.4. So in place of the x, we have 3.4. Well, how do I add decimals? Well, we have to go back through all the way back to early on in Unit 2 and Unit 3 where we did decimals. We have to line up our decimals. That has to be the beginning. You have to know that by now. And if you don't, then you need to put forth the effort to persevere, go back into your books and look and learn how we deal with decimals. We line up our decimals. Then we bring them down. If I have any zeros to fill in, then I do. Here I don't. So now I just add, going from right to left. 4 plus 5 is 9. 3 plus 3 is 6. 6.9 equal to 7.9. No, it's not, right? So those are not equivalent. Once again, that equal sign with a slash through it, that means it's not equivalent. We just simply say, no, it's not a solution. It does not give me a balanced equation on the left and right. So now we have to do another math problem. Where the x is, we're going to substitute in with the next number, which is 4.2. So I have in the number sentence 4.2 plus 3.5 equals 7.9, but I have to show the math that we're going to do. So we line up our decimals. We have 4.2 plus 3.5. Decimals are lined up. I'd fill in with zeros if I have any. I don't. I bring my decimal down, and then I add from right to left. 5 plus 2 is 7. 4 plus 3 is 7. Is 7.7, 7 and 7 tenths, equal to 7.9 or 7 and 9 tenths? No, they're not equivalent. So it is not a solution. We assume that it's going to be a yes for the 4.4, but we have to prove it. We have to do the math. So we're going to show our third math problem. So we're going to show that we're adding 4.4 and 3.5. We're going to line up our decimals. We're going to bring our decimal down. I don't have any zeros to fill in, so I add on the right, which gives me 9. I add on the left, which gives me 7. And that tells me that on the left, I end up with 7.9. Is that equal to 7.9? It is. It is equivalent. So what we're finding is that 4.4 is a solution to that equation. Now this one has a different approach to it. It tells us that we're going to use a different method in order to figure out what x is equal to. So we're going to be trying what is called the guess, check, and revise strategy. And what that means is exactly what it says. We're going to guess a number. We're going to check to see if it works. And if it doesn't, if we've gone too low, we have to go bigger. If we've gone too high, we have to go smaller until we find the correct answer. So don't let yourself get all confused or worried about how to do it. We're just simply going to plug in for what we know. But maybe you're looking at the equation saying, well, we've got this number and an x. Well, I don't remember what that means. So we have to commit this to memory, right? This is a key idea of algebraic expressions. We have to remember that anytime I have a coefficient, a number, directly touching a variable, a letter, also known as a number touching a letter, or we could have a number touching another number inside of a set of parentheses, or a variable inside of parentheses, or math problems inside of parentheses. If it's touching the parentheses, all of those mean to multiply. So each and every time I have to realize that that is a multiplication problem. And therefore, when I start thinking about guessing what math number I'm going to use, then I just have to remember I'm multiplying each and every time. And then when I'm guessing, I'm going to substitute in. And once again, substituting in means I'm going to take a number and put it in place of the variable. So just a caution, let's say you're going to use 3. That wouldn't be a logical guess for x. But if I was going to use 3, remember, I have to indicate that that's multiplying by 3. I can't just put 4.53 because that's not going to work. So if I know that I have a coefficient touching a variable and I'm going to substitute in for the math and I'm just going to start trying numbers, right? So I have to stop and let's think logically. You've done multiplication for several years now, and you know that if you multiply by a 10, you just add a 0 to the end. Well, one of the things you learned in 5th grade, and then we reviewed earlier this year, is that if I multiply a decimal by 10, then I just move my decimal point to the right one time. So if I would multiply 4.5 times 10, that would give me 45. But, I need more. I need quite a bit more. So what if I double it? Let's see if we multiply by 20. So if I have 4.5x, I'm going to put a 20 in place of my variable of x. Once again, notice that it is shown inside of parentheses, so you know you're going to multiply. So you take 4.5 times 20, multiplying by 0 is just 0. My second number tells me to bring down to 0. Some of you haven't learned this process yet, and yet you still get wrong answers, so learn it, commit it to memory. It'll help you from this point all the way forward throughout life anytime you have to multiply. 2 times 5 is 10. Put down a 0 and carry on addition of 1. And then I have 2 times 4, which is 8, plus 1, which is 9. When I add them, then I need to count my decimal spaces. I have 1. So I move my decimal from right to left 1 time. Is that going to give me enough? Now I need 135, so you can see that 90 is not equivalent, right? It is too small. The explanation says 90 is less than 135. All right, so what are we going to try now? Well, the book shows us that now we're going to try 25. All right, let's see if that's enough. So I'm going to take, once again, plug in for the x. I'm going to put a 25, number touching parentheses. I know it's multiplication. I'm going to start multiplying with the 5. 5 times 5 is 25. Put down my 5, carry my addition of 2. When I take 5 times 4, I get 20 plus 2 is going to be 22. And then I bring down a 0 because my second number always tells me to bring down a 0. Now I'm going to multiply by the 2. 2 times 5 is 10. Put down my 0, carry my addition of 1 now. And then 2 times 4 is 8 plus 1 is 9. All right, so when I add those, I start on the right-hand side. I end up with 5 and then 2, and 9 plus 2 is 11. How many decimal spaces are in my math problem? There's 1. So I know I'm going to put my decimal from the right to the left 1 time. That gives me 112.5. And once again, that's not enough, right? It's too small. 120 or 112.5, 112 and 5/10 is less than 135. All right, let's jump up to 30 and see if we get enough. So where the x is, where my variable is, I'm going to plug in with the 30. I end up with 4.5 times 30. I start with my 0, and 0 times anything is 0. My second number tells me to bring down 1 0. Then I can multiply with my 3. 3 times 5 is 15. Put down my 5, carry my addition of 1. And then 3 times 4 plus 1, that'd be 12 plus 1 is 13. Well, that's just going to be the same number, 1,350. I have one decimal space, so I'm going to move my decimal from right to left 1 time. That gives me 135. That is my equivalent answer. So I know, yes, 30 is indeed equivalent. So I have 135 is equal to 135. Now, instead of having to do a whole bunch of guessing and checking, one of the processes you can do is use your handy dandy calculator. You can use it to help you get narrowed down, figure out even what the answer is, but you still have to show me your math problem that you do, all the steps, solving for it, so I know you can get to the right answer, because that's what math is all about. As we go through these, then what we're going to see is we're going to have two different approaches that we're going to use. They're either going to say, hey, here are a couple of different options to plug in for your variable. When I'm doing those, then I have to show either it's a yes, it is a solution, or it's a no, it's not a solution for each of them. If, let's say, in this example, we get to the 3, we plug it in, we find out that's a yes, I can't just be done because there are two other numbers that I have to try. So this is worth multiple points because there are multiple problems that I have to do and also multiple answers that I have to go through. So I have to do each and every one of these. The other way is then we're going to see these equations and we just have to figure out by the guess and check method as to what is the actual answer for the variable. With these, it becomes a little bit easier because they tell you what to try. So for each one, we're going to plug in for the numbers that they give us. So we have the equation of p plus 9 and 7/10 equals 13 and 7/10. So I'm going to plug in with 3, then I'm going to plug in with 4, and then I'm going to plug in with 5. As I'm doing it then, plugging in, once again, just means I'm going to substitute. I'm going to take a value and I'm going to put it in place of my variable. This is addition. We're going to try the 3. So instead of having the p out front for the variable, we're going to add with 3. Now, I have a whole number and I have a decimal. Once again, adding whole numbers and decimals. I have to line up my decimals, and when it's a whole number, I have to add the decimal to the end of it. That way, the 3 is lined up with the 9, and then I have to fill in with zeros. Once I have it stacked, I've lined up my decimals, I fill in with 0, I'm going to bring my decimal down, then I can add. So 0 plus 7 is 7, 9 plus 3 is 12, 12.7 is not equivalent to 13.7. So that's an NAS. You are able to write NAS as an answer, And all that means is not a solution. I'm going to do the same thing with 4 now because that's what they give me. I want to plug in the 4 for the variable of p. I want to line up my decimals. Once again, it's a whole number that doesn't have a decimal with it. So I simply put it at the end of the number. That way, the 4 and the 9 are lined up. I fill in with zeros, and then I bring down my decimal. 0 and 7 is once again 7. 4 and 9 is 13. And that's what it tells me should be equal to. So that is a solution. Now I'm going to try 5. Why? I already have a solution at 4 because it tells me I need to try 5. So I'm going to try 5 and I'm going to give the answer of yes it is or no it isn't. So when I do it, I'm going to plug in the 5 for the variable of p. I'm going to add a decimal to the end of it so I can line up my decimals. I'm going to fill in with zeros and then I'm going to bring my decimal down. 0 and 7 is still 7. 9 and 5 is 14. 14 and 7 tenths is larger than 13 and 7 tenths. They are not equivalent to one another, so that is simply an NAS. Notice it once again says to complete the table, so we had to do the work for each of them. We had to then give an answer that it is a solution or it is not a solution. So what is the solution? Well, that's simply the 4. All right, so I want you to try this one. You don't have to do a table unless it helps you, but walk through the processes to do it and then come back and check. So hopefully you have an answer and you can see that we have a variable plus 4/5 and we want it to equal to 2 and 4/5. This should be really easy and you could probably do it as mental math. However, we don't do mental math in 6th grade. We show our work so that we understand and we can display that we do know how to add, subtract, multiply, divide with all sorts of different forms of numbers. So we're going to have 3 problems hopefully worked out on our paper because that's what I expect of you. So once I have that, then instead of the m, I'm going to plug in a 1 and we know it needs to be equal to 2 and 4/5. So this is where some of you are still getting confused. You don't remember that when we stack whole numbers and fractions, we have to stack where the whole numbers are lined up, the fractions are lined up. That's why this really could be done as mental math if I didn't expect you to show your work. Because then when I say I have 4/5 plus nothing, I have 4/5. And when I have 1 plus nothing, I have 1. So we end up with 1 and 4/5. That's not equivalent to 2 and 4/5. So now I do the 2. I plug in for the variable a 2. We know it has to be equal to 2 and 4/5. I line them up according to fractions and whole numbers. I can see that I have 4/5 once again, plus nothing is 4/5. 2 plus nothing is 2. So I know that that's going to be my answer. That is a solution. But I also have to check the 3 because that's what it tells me is I have 3 different numbers I have to try. So we create the math problem again. We have everything lined up according to whole numbers and fractions, and we just simply have to drop them down, and we can see that 3 and 4/5 is not equivalent to 2 and 4/5. So my solution is 2. All right, so what about the guess and check? Well, the guess and check, we're just going to go through it, right? We're going to figure out what it is we need to do and what we need to come up with. So Nevaeh is building a door that is 36 inches wide using wooden planks that are 4 1/2 inches wide. Use a guess, check, and revise strategy, right? So we have 36 inches. We're going to cube it. That's my units and my numbers that I'm using. I also have 4 1/2 units. All right, then I need to know what I am being asked to find. To find P, the number of planks. Okay, well, what is my clue words? Well, it's the actual equation. I have 4 1/2 times P is equal to 36. Did you remember that 4 1/2 touching P means multiplication? I hope so. And therefore, we're going to evaluate. We're going to go through the process that it indicates, which is the guess, check, and revise. Don't freak out about this. This is not difficult. It's just simply trying and plugging it in. So if we start guessing what it is that I need to multiply by, Well, let's see. So 4 1/2 is equal to what as a decimal? Hopefully you thought, well, that's 4.5, right? Because 1/2 is equal to 0.5. So if that's the case, and as we said earlier, I multiply a decimal by 10, I just move my decimal to the right one time. And that gives me 45, and that's too much. So I know that it can't be multiplying by 10, right? So I have to go less. So let's try 8. So when I try 8, so I have 4 1/2, and I'm going to multiply by 8. So if I take 4.5 instead of 4 1/2, I don't have to make an improper fraction and then put 8 over 1 and then try to cross reduce and all that. I can just have 4.5 times 8. And when I plug that in, does it give me 36? Well, 4.5 times 8, 8 times 5 is 40. I put down my 0. I carry my additional 4. 8 times 4 is 32, plus 4 is 36. I have one decimal position. I'm going to move it from right to left one time. It does give me 36. Now, if I didn't know my multiplication facts, then I have my handy dandy calculator that I'm able to use. However, I need to make sure that I'm showing my math problem. If you just put it down, you're not showing me your steps, you're not showing me your math, I need to see your math. Because once again, on the standardized test, the first day that you do it, you don't get a calculator. You have to be able to work it out on your paper. And I need to be able to see that you can do that. So we end up with the answer of 8, right? No, because it's a word problem, therefore I need a label. What is my label? Once again, we go back to what's underlined in pink, and it says the number of planks. So we have 8 planks. Is that the answer? Yes, it is. All right, so I want you to try it. Once again, I'm strongly going to suggest that you cube it so you can work through it and figure out what the answers are, and then come back and check. Let's see how you do. So hopefully you have an answer. Hopefully you've cubed up your question. You've noticed all of the important information, and then you're going to ignore what is not important. So this year, students ate 100 pounds of broccoli. All right, so that's a number and a label in the Walnut Springs Middle School cafeteria. This is 6 1/4 times, 6 1/4 times as much as they ate in the previous year. Use the guess, check, and revise strategy to solve the equation that 6 1/4 times b is equal to 100 to find, so this is my question, the number of pounds of broccoli the students ate in the previous year. All right, so 6 1/4 times what is equal to 100. That is my clue words. That's my math that I'm going to be doing. So we box it, and then we start figuring out that we got to guess, check, and revise. All right, so 6 1/4 times b. Once again, trying to use mixed numbers and making it an improper fraction, all that, that becomes much more difficult. So what if I change it to a decimal? Well, what is 6 1/4 as a decimal? Some of you know automatically what 1/4 is as a decimal, and some of you are still struggling. So I'm going to strongly suggest that when you see 1/4, you think of a dollar, right? Because the nickname that we call 1/4 is a quarter. So if I know that that's a quarter, and I think about quarters, I have a dollar, and it's always able to be divided up into 4 equal amounts because I have 4 quarters, 4 over 4, that make up a dollar. So one of those is just equal to 0.25, 25%, 25 cents, or 25 hundredths. So if I take 6.25 and I multiply it by 10, that means I move my decimal from left to right one time, then that's going to give me 62.5. That's not enough. So if that's not equivalent, then I can't use that. Well, what if I double that, right? If I double the 62.5, so 62.5 times 2, does that work? That gives me way too much. So now let's find the middle. So I tried 10 and I doubled that, and I tried 20. That didn't work. What about 15? Well, once again, I can use my handy dandy calculator to see if that's going to give me close enough. But I'm just going to work it out because, once again, on your standardized test, you don't get a calculator. You have to be able to work it out in our guess and check method. So I'm going to take 6.25 times 15, and I start with multiplying by the bottom 5. 5 times 5 is 25. Put down my 5, carry my addition of 2. 5 times 2 is 10 plus 2, which is 12. Put down my 2, carry my addition of 1. 5 times 6 is 30 plus 1 is 31. Then I have the 1. So my second number tells me to bring down a 0. And then 1 times anything is itself, so I just bring down 625. Everything's lined up, so I'm going to add. I have 5, I have 7, I have 3, I have 9. How many decimal spaces are in my math problem? There are 2 of them. So I'm going to move my decimal from right to left 2 times. That gives me 93.75. And that's still not enough. If it's not quite enough, it's close. Let's try one more of them. So I'm going to add 6.25. I'm lining up my decimals. I bring down my decimal, and then I'm adding from right to left. I get 5 and 5, which is 10. Put down my 0, carry my 1. 7 plus 2 plus 1 is 10. Put down my 0, carry my 1. 6 plus 3 plus 1 is 10. Put down my 0, carry my 1. 9 plus 1 is 10. I get 100, which is what I needed. So how many times did we go in? Well, we did 15 for the first math problem, and it wasn't quite enough. So we did one more. So we know that the answer is 16. 16 what? 16 pounds. Is that what you got? If not, do you know why? And if you don't know why, come and ask, and I'll help you figure it out, as long as your work is on your paper. All right, so you have one assignment that is due in the morning as you're working through it. If you have questions and you've taken your notes and you've paid attention, you followed along, then you can come and ask your questions. If you didn't take your notes, you can't show me that you took your notes and that you followed along, then you need to go back through this video.